Thank you very much. So I'm very glad to give a presentation of our work, SilhouetteTell practical video identification, leveraging blurred recordings of video subtitles. So this work was mainly performed by my PhD student Guanchong, who unfortunately cannot come this time. Video viewing is not strange to everybody, right? So this is something we do almost every day, is that right? So no matter it's on YouTube, Amazon Prime Videos, Netflix, watching videos has already become part of our daily life. So, but what we watch usually reveal what we are. So it may disclose our political views, like health information, religious beliefs, even sexual orientation. Such information can be utilized for targeted advising. And the most importantly, they can create very serious consequences. For example, they may be generate like discrimination in hearing or like cyberbullying, so etc. So that's really we do not want to happen. And this brings us a privacy threat, which called video identification attack, which aims to enforce videos that victims are watching without authorization. So now let's discuss existing attacks. So in general, they can be divided into three types. Content matching, so that is easy. So if I'm near with a victim, I can see the content. I can listen to the audio signal. So then I just match the content. I can enforce the video. And also like traffic analysis. Oh, I think like a lot of you working on traffic analysis. No matter you utilize malware, or utilize like non-invasive traffic analysis, utilize special equipment such USRP to like passively collecting traffic, and then you perform a so-called video fingerprinting. And also another is about if you have special equipment, right? So video viewing can be reflect well like the glasses or the wall, and then you can utilize such information to enforce videos. So, but as that, when we are aware of those attacks, we may take precautions, right? So for example, when we tell the screen, and we can see whether anybody is around us, right? If I see within 5 meters, some strangers are there, so I just like stop watching. So definitely like content watching may not be available. And also, I can watch video offline. So why I need the Wi-Fi, right? I can download and watch. And also like, if you do not have special equipment, so like optical-based like method also may not work. Then the question is that can attackers still identify the video you are watching? And our work answer the question, yes. Let's see how we do that. So first, let me give you just a frame. So this frame is a blurred frame, blurred subtitle, and you have no access to the audio. So what you do, right? So if you are machine learning guy, so the first in your mind is that what I utilize the OCR, right, to recognize optically sensed content into machine recognizable text. Unfortunately, it does not work. Okay, what about I utilize recent like image captioning algorithms, right? So that can generate like a natural language description of images. So we utilize clip cap. Unfortunately, it still does not work. So, but let's revisit this frame, and we can see on the right corner there is a white area, right? It's blurred subtitle area. So we call the shape of subtitle region, or I would say Silhouette of subtitle region. So such Silhouette varies with the content, and surprisingly, that is enough for us to enforce the videos. Let me briefly introduce about background of subtitles. So subtitles can be open and closed. Open subtitles embedded in the video, you cannot turn it off. And open subtitles, you can turn it on, you can turn it off. And the subtitles often you can download in a specific format, and as the slide shows, so it shows subtitle index starting and beginning time, start and ending time, and the content. And the subtitle can show in different areas in the frame. And according to surveys that adults under 30 years old, like 63%, they prefer to turn subtitles on. Particularly, right, so if you watch videos that is like in foreign language, so we need subtitles for understanding. And also in very loud environment, right? So we do not listen, but we just see the subtitles. All right, so let's discuss our threat model. Is that a victim watches subtitled videos on any device in public places, and attacker records their screen from a distance using only an RGB camera in a smartphone. And we do not depend on malware. There is no special equipment, no user-specific training, and no traffic analysis. Our work is called SilhouetteTell. It can be divided into phases: training phase and inference phase. In the training phase, we build a mask RCM model to get the Silhouettes. So you may have a question, right? Still, why we utilize existing segmentation algorithms, right? So we find the existing method like MSER or like GrabCap that we call like coarse Silhouette extraction. It may not be accurate, and that's why we train a mask RCM to get the like Silhouettes more accurately. So we call it refined Silhouette extraction. So with the training, we get a sequence of Silhouettes, and the next step is to import the videos. So one challenge is that with the Silhouette, with like a sequence of Silhouettes, we want to distinguish whether two successive Silhouettes come from the same like subtitle. So we utilize the IOU intersection over union, right? If that is low, so we see they from different subtitles. As see the case 1 and the case 2 and case 3. Case 1, they are totally separate. Case 2, they have different line. So in the case 3, they have the same height, but they also like partially overlap. And in those cases, easy to do that. And for case 4, so this is challengeable way to see they have the same height, right? So obviously, if this case, you only utilize IOU, that is not enough. So that's why we utilize preprocessed frames to further confirm whether they come from the same subtitle. Now, as that's six Silhouettes, right? So then we extract the features. So what we do, we extract the spatial feature and the temporal feature, and then here is that we sort them based on the height, right? Based on the height, and then we sort them, and we can see we have 2 of lower height screens and 4 of longer height, like Silhouettes. And then we get the spatial temporal feature is such a vector. And what we do is that we create the video, the sliding, do the matching, right? If we find a match, so like that, if this is the a matching algorithm, if we find a match, so that would be like a candidate. All right. So now let's discuss about our evaluation. So we have 300 movies from different services, and we record at more than 3 meters, and utilize a smartphone, and we utilize metric top K accuracy. And so this case study shows that we have a 2-minute clip, and with more like subtitles, that the candidates will be small, right? So that's what we have. And also for the overall attack impact, we can see our algorithm can achieve very high recognition accuracy, and we can see top 1 accuracy is almost like above 91%. And we also discuss like defense strategies. Of course, very simple one, disable subtitles. And also you may utilize our fast-cat subtitle Silhouettes, or you can utilize privacy screen protectors. So in conclusion, so we propose SilhouetteTell, and we develop our spatial temporal correlation algorithm, and we conduct extensive experiments to validate the effectiveness and the robustness. Thank you very much, and welcome any questions.